Hello, this is Mr. Buffington, and we are doing some transformations with similar figures today. So we're going to transform similar figures, which is a little different than what we've done in the past. Let me explain why. Transformations we've talked about in the past have been isometric. Dilation is a different type of transformation. Dilation is a transformation that actually shrinks or expands a shape. Okay, so we're going to be doing that with polygons today, but a dilation changes the size of things. And when the size of a figure changes, it's not called an isometric transformation. It's not a transformation where the figures remain congruent. It's a transformation that makes the figures stay similar, so they have certain properties that are the same, but they aren't exactly the same figure. So while we will be using translation, rotation, and reflection, we'll also be adding to that the dilation. All right, so let's do a quick recap. Transformations. What transformations would happen to our original figure to make it into our second figure? Notice our original figure will always have A, B, C, and our new figure is A prime, B prime, C prime. Those little tally marks there, the prime quotation there, a single quote, that is going to tell you that that's the new figure versus the original figure. So what did we do? Well, to make it from our original figure triangle into our new triangle, we had to do a couple of things. One, we reflected it over the y-axis. So that made it look like this. So we reflected it over the y-axis, and then we translated it down 4 places. So we moved it down 4. So it started up here, dropped down 4. All right? These figures are congruent. They're still congruent because we've used reflection and translation. For the next 4 things that we're going to do, we are going to actually add dilation in there, and you'll see that the size of the figure will change, making them similar but not congruent. Let's take a look at it. So how do I go from my original red square to this larger blue square? Well, first of all, I translate it left 4 and down 4. The way that we would write this is that xy becomes x minus 4 and y minus 4. X minus 4 is taking it left 4 spaces, and y minus 4 is taking it down 4 spaces. So that's going to move it to here. All right? It's gone over to the left 4 and then down 4. Now we have to dilate this figure. Now dilation through the origin is probably the easiest type of dilation, so I'm going to go ahead and do that. We're going to dilate it through the origin with a scale factor of 2. When you dilate through the origin, basically what you do is draw a line from the origin to each of the vertices. And then notice that this is 1 step. So this would be a dilation of 1. We are going to dilate it with a factor of 2, meaning that instead of taking 1 step, we're going to take 2 steps down. And so it becomes this figure, that figure that it was before. So it's taking 2 steps, it's becoming a dilation factor of 2. All right? And it's through the origin, meaning that the origin's going to go and hit our original, well, our translated vertex, and it's also because it's going through the origin, that's going to also hit our new vertex. So from the original figure to this new figure, those are the steps. These figures are not congruent, but they are similar. All right, so in other words, they have certain properties that are the same. Their angle measurements are the same. Their proportion of their sides is the same. Okay, these are similar figures, but they aren't congruent. They're not exactly the same size. Let's look at these ones. What happened to the original figure to give us this new blue trapezoid? Well, we start out by moving it right 5 and down 1. Okay, again, that's a translation that would look like this: x plus 5, y minus 1. We went right 5, down 1, moved it to there. Then we dilated through the point 1, 1. Now this is a different type of dilation, but basically you start at that point. That's the dilation point of 1, 1, and I'm going to draw lines through each vertex of this trapezoid. And then I'm going to do the same thing that I did before. If this is one step from here to here, then I'm going to take it one more step because it's a scale factor of 2. So instead of going 2, I'm going to go 4. Right? If that's one step, I'm going to go a second step up to there. So you notice that the point C is going to be up here. The point B, instead of being here, is going to be up 2 more. And the point A, it's kind of a funny point that's off there. Instead of being up 1, it's going to be twice that. And you'll see that when we do this scale factor. Okay? Now these ones, not all of them line up on points that are really easy to see, but you can clearly see that we're doubling, or the scale factor of 2 is going up. And because all of our points focus on the point 1, 1, we say the dilation was through the point 1, 1. That's our center of dilation right there. Okay. So there we go. Again, the figures are not congruent, but they are similar. So their angle measurements are the same, and they are proportionally the same. In this case, the scale factor of 2 means that the side lengths are going to be twice as long in our new figure as they were in our original. Let's look at one more with a scale factor that actually shrinks it down. What happened that brought us from the yellow triangle down to this green triangle? Well, first of all, we reflected it over the y-axis. So we're doing a reflection, and then we're going to do a dilation. This is a dilation of 1/2. So we're going to bring everything down. Instead of making it larger, we're making it smaller. So because the dilation is through the point 1, 1, I'm going to again start it on my point 1, 1 and draw lines through each vertex. Then I take the points and I'm going to divide them in half. So this is a nice easy one here. The distance from C prime to B prime is 2. I'm going to divide that in half. So my new figure, see that? Reduces it down by half. And because this is a 90-degree triangle, I can just draw my line straight up to there. Okay? This is also half. Notice the distance from here to here. That is exactly halfway through. Okay? So that's how we would reduce it down. So this is a reflection over the y-axis, and then a dilation with a scale factor of 1/2 through the point 1, 1. Notice that the small scale factor of 1/2 makes the newer figure smaller than the original figure. All right? It's still similar. It still has the same angle measurements, and the proportions of the sides are the same, but the size is different. So they are not congruent. They are similar figures. All right? So remember, transformations. The dilation is that shrink that's going to change the shape's size. It makes the shape similar, not congruent. And that's different from our translation, rotation, and reflection that we've talked about before. Hope that lesson was helpful for you. Here are your Common Core Anchor and PA eligible content. Have a wonderful day.